right, class, so I've gotten a couple emails about Venn diagrams, and then I realized Venn diagrams would be a great project topic for Chapter 5, so I decided to go ahead and make a PowerPoint talking a little bit more about Venn diagrams and some of their applications outside of mathematics, as well as doing some math-based examples. I want you to know that along with this video, I am posting, what am I posting? I'm posting a Word doc of a fillable Venn diagram, if that's something that interests you, a biography of John Venn, the one who invented Venn diagrams, and a couple of articles about color theory. And you'll see how that relates to Venn diagrams at the end of this PowerPoint. So without further ado, so what a Venn diagram does is a Venn diagram shows the logical relationship between groups, we call those sets, right, in math theory, of things, right? So in mathematics, we typically use sets of numbers. Venn diagrams are most often shown as two circles that intersect in the middle of a page, but that depends on how many groups you have. They can have up to 5 circles. I'm going to show you what a 6-circle Venn diagram looks like. It's kind of crazy. My recommendation is to not use that as a comparison tool when you get more than 5 groups. So attributes that are unique to a specific group are listed in the circles, and those that are shared are in the intersecting space. One thing we can use, as I'll show us in some non-math applications of Venn diagrams, is we can use it to compare not only to objects like groups, we can use it to compare concepts, right? We could use it to compare socialism and communism, right? Where do those overlap? What differences do they have? But we can also use the Venn diagram in math. As you guys saw, it was in sections 5.2 and 5.3. So here's kind of a silly Venn diagram I found. So where do beef and wheat overlap? They overlap in a hamburger, okay? So this is an example of a 2-circle Venn diagram. We can also have a 3-circle Venn diagram. As you can see, each circle overlaps with the other. Here's a 4-circle Venn diagram. Things are getting a little more hectic. And here's a 5-circle Venn diagram. So this still works, right? We still have, each group has its own unique section and then where it overlaps with every other group. This gets a little weirder when we have a 6-circle Venn diagram, just so you see what this can look like. It is not great. This is not great. So each side shape is outlined in a different color, right? But then they also have little free floating spaces to make sure that they get in every possible section. So I would only work up to 5. Each Venn diagram, what it does is it divides our universal set, that's the whole area, into what we call basic regions. So here are the basic regions for 2 and 3 Venn diagrams. There we go, 2 and 3. So here are the basic regions. And we can use these basic regions to solve questions about sets and to solve questions about counting. So let's go ahead and first do some examples where we practice shading specific regions of a circle. So let's shade the following regions of this 2-circle. So I have my universal set here, U. I have 2 sets. I have S and I have T. Where this overlap is in the center right here, that's going to be the space S union T. But now what I want to do is I want to solve each of these problems. So for problem number 1, I want to know what S prime of T intersect T prime of T. So remember, S prime is the complement of S. And that means that S union S prime equals everything, right? It's going to equal our universal set. And that S intersect S prime is going to equal the empty set, which is nothing. So first thing I need to do is highlight S complement. So that's everything not in S. So that's going to be all of this over here. Oh, wait, T is not an S. All right, then I need to take a look at everything that's not in T. So that's going to be everything outside of T. So all of this is not in T. So what I'm looking for is where the orange and the green occur at the same time. You could use an eraser to erase where they don't occur. So they don't occur here, that was just orange. They don't occur here, that was just green. Or what you could do is highlight in a different color. So all of this right here that I have highlighted in turquoise, that is S prime intersect T prime. So the complement of S intersected the complement of T. All right, I've completed that example. So I'm going to clear my markings and let's start over again. I've got my universal set. I've got S and T, and let's work on problem 2. So problem 2 is S complement intersect T. So where is S complement? Let's go ahead and highlight this in green. So S complement, right, that's everything that's not in S. And then T is everything that's in T. So let me just highlight T. All right, so where do these overlap? I'm going to go ahead and highlight this in teal. I want to know where these two things intersect. That's why I'm looking at the overlap. And that's going to be in this area right here, this kind of crescent moon shaped space. All right, so here I have the complement of S intersect T. My answer is in teal right here. All right, next I'm going to give us a second to look at this, make sure we're all on the same page before I clear my drawing. So let's go ahead and clear this. I'm going to look at my third problem. My third problem is S union T complement. So remember, union, it can be in one or the other. It doesn't have to be in both, whereas the first two examples we were looking at were intersections. So here are my universal set. Here I have my set, S. Here I have my set T. I'm going to go ahead and highlight S. That's going to be this area right here. All of this is S. And then I need to highlight T complement. Remember, T complement is everything that's not in T. So here's T complement. Now I'm not looking for the intersection. In this case, I'm looking for the union. So I'm going to highlight in pink everything that's in one or the other. I thought I could make my pen bigger. Okay, so it's all of this. All of this is in the union. Anything that is green or orange or pink, I was trying to make it all pink. That is our answer to problem number 3. Beautiful.